Hello, this tutorial will be about algebra test, and more specifically the first one is on the most basic skills that you'll need for the algebra test, such as adding fractions. The first question in the algebra quiz that you need to do is about simplifying the fraction as much as possible. For example, question 1 asks you to add two fractions. C over 2 plus B over A. You can see that letters and numbers could be involved. If you've already done it recently, you should remember that you put these to common denominator and then you add C times A plus 2 times B. So that's the rule. One of the common mistakes students do is forget to bring it to common denominator and just add numerator and denominator. Obviously this is not a very nice mistake and hopefully to be avoided in your test. Before we go further, I just want to explain why we have such a rule, what happens. So algebraically, how do we bring to common denominator here? So what we do is we take this fraction, C over 2, and because the other fraction's denominator is A, we modify this fraction by multiplying simultaneously numerator and denominator by A. This does not change the fraction, and we'll rationalize this visually later, but at this stage we just go and multiply this fraction by A, numerator and denominator, and this one we multiply by 2, again multiplying numerator and denominator. Again, the choice of 2 is because we've got 2 in here. Now we have identical denominator for those two fractions, and we can just add them as we did in here. So that's the first question. Now, why could we multiply something like that and still have an unchanged fraction? So here some visualization might help. Imagine that you need to add 1/2 plus 1/3. How do we represent this visually? Well, you have a whole of a pizza or cake, 1/2 of a cake will be represented as half of the circle. So how could we represent a third? Quite similarly, we take the circle and we just divide it in 3 equal parts. Hopefully this is as equal as I need, and that will be a third of it. Now visually we can add them, but how do we count? Well, it turns out that this 1/2 could actually be divided further. So I'll first divide here further. I can divide this whole circle into 6 pieces of 1/6, because 1 is just 6/6. So if you take 6 of these pieces, you get 1, but 1/3 will be equal, we can quite visually see that, it's equal to 6. So therefore, here we have 2/6 instead of 1/3. What about these? Well, here it will also help to divide this piece further into 3 equal pieces. And in a way, we also divide these into 1/6. And you can visually see now that this is 3/6. So visually, we can recognize now, after dividing it into 6 pieces, that 1/2 is 3/6. So after we've done that, after we achieved common denominator 6 in this case, we can easily add these together and find 3 plus 2 gives us 5/6. So that's the same as we done for this question, only here we had letters as well as numbers. Here we deal with numbers and we represented them as fraction or a circle, and therefore it was easier for us to visually remember why it happens like that. But in a way, everything is similar, because what we've done here, we multiplied algebraically, multiplied this fraction by fractions numerator and denominator by 3, and this one we multiply by 2, and then we've got this expression, and we can add those fractions together. So if you for some reason want to add top and bottoms of the fractions, if you ask such a question, you should maybe remember this simple example and think visually what the answer is, and then hopefully not to make mistake like that. So that was adding fractions. Our second question here is on multiplying fractions, and again there could be I need to be careful to write the correct question. So here we have to multiply g over 3 by h over f. How do we proceed? In this case, for multiplication, we're multiplying each by each. Again, how do we rationalize it? How we think about it? This example or similar example with numbers might help. So if you take 1/3 and multiply by 1/2, when you multiply something by half, for example, you can multiply 1 by half, you get 1/2. So basically you're halving something. So if you multiply a by half, you get a divided by 2. It becomes half of what you had. Here we get half of 1/3, and we already see what 1/3 is. If you halve it, you get 1/6. So therefore the answer is 1/6, and in this specific example it is achieved by multiplying numerator 1 by 1 and denominator by denominator, which gives us 6. So that's another motivator for the multiplication of fractions. Now we want to do division of fractions example. So I'll go here. And the example here, let's do the numerical example, which is number 6. So we need to divide 7/15 by 205. How do we proceed? The rule is that you leave the first here unchanged, whatever stays here to be divided, and then multiply that, and here you swap, and numerator goes denominator on the bottom here goes to numerator, and this stays here. So It just goes upside down. 5 goes up, 2 goes down. And then, even before I multiply, because you need to simplify these fractions as far as possible. So if you just give me an answer of 35 divided by 30, you'll get a cross here because you have not simplified as far as possible. Therefore, even before multiplying out, and you can simplify it here obviously by noticing that you can divide these by 5 and these by 5, but it will be even simpler if you notice that here you've got 15, you've got 5, and you can divide by 5, here getting 1, and here getting 3. So therefore here you've got 7 by 1, and here 3 by 2 gives you 6. So that is a correct answer. Now once again, these rule potentially as a possibility for forgetting what you do, how you handle it. And I suggest you remember this example where you divide 1 by 1/2. Essentially, when you divide something by something, for example, if you divide 10 by 2, you just want to see how many 2's are in 10. And in that specific case, 10 divided by 2, how many 2's are in 10? So it's 5, because 10 is represented as 5 2's. If we bring similar thinking here to fractions, if you have 1, how many halves are in 1? And we already pictured that. There are 2 halves in 1. So the answer must be 1. How do we achieve it? Well, this is equal to 1. We leave this unchanged. Times, and here 2 goes to 1. 2 goes to numerator, 1 stays in denominator, and that is equal to 2. So if you're forgetting some of these rules, in other words, you can, well, you shouldn't forget them in the first place, of course, but you could get out of it by thinking, and maths is more about thinking, so thinking is encouraged. If you need more examples, more motivation on fractions, please go to Khan Academy. This is a free resource available for everybody, and there are many more and probably better tutorials on this resource than we provide at the moment, and there are many examples where you can check yourself, you can do some assessment, you can do some tests. So when students ask me for more examples of algebra quiz or algebra test, I say we give you one to get the idea, and then you can use these other resources to really generate a lot more questions. But importantly, study the algebra quiz, not only for passing it this time, but actually so that you have it in the future. So that's for fractions, and we will continue later to do some other algebra, to revise some algebra.